meters. You can use a standard value for cable size, but I will explain it then.
Yeah,
Uh,
okay.
he's probably in still
I
going
think
out for
he's
it.
yeah, he he will join when
Oh, yeah, okay.
he ready, so we can start now because I already record.
Yeah, okay, it's fine.
Okay. Yeah.
I will share my screen. That will be the easiest way, I
Yeah,
think.
okay. Yeah.
So, no, wait. Yeah, this one. Yep. Now you can see it, I think. So first of all, in the projects, if you make schemes and so on, you can place them directly on the schemes form for me. You don't have to put it in a communication folder from Vietnam to EU. We work on the same file, so you can just put them
Yeah.
here.
I don't see their screen is
Ah,
dark.
okay.
It's
Sorry.
black.
That's not good. Wait. I will
Okay.
click another one. No, I need to do it otherwise. Yep, like this. Yeah.
Okay, I can see it
Yeah.
now.
So for the projects, if you make block schemes or so, you can put them here directly. You don't need to
Yeah.
put it in another. So we always work on the same files. So I
Yeah.
saw you copied this one here, the inderdaad schema for apartments, but also the general areas is on there. So I will start from that for an apartment building, for an
I just
apartment
yeah,
itself.
I just finished the how to say the attachment only for the other parts not yet. I just copy the
Yeah,
typical yeah.
yeah, I know. I saw it was the copy of OC. I know the
Yeah.
project. Uh, so I saw you didn't change it yet, so no problems.
Yeah.
Um, for an apartment building, that's clear, I think. How you build
Yeah.
it up, that's not quite a big issue, I think. Eh?
Yeah.
For the yeah, general stuff, how you start on it, we have a template for schemes. I will put it. I didn't. I don't know if I put it here in the communication folder. Electricity templates. No, I will put it there right up. Here I have. No, those ones. This one. Let's go there. Go ahead. Come on. Yeah. So this AutoCAD file is a template we use to start from. So you can copy it from another project or you can use this one. Um, this one has several options where you can choose how the building is connected to main voltage room that is in the building or outside the building, etc. Um, if it goes open, come on. Yeah. So if you look at it, so there's a template. So you have the option here with the main voltage room outside the building, or you have the option where the main voltage is connected to an ALSB that's in the building, and that's one ALSB. Yeah, the ALSB is placed directly next to the main voltage room. So you can choose about those parts. Also, we have a typical principle for safety installations with the generator. So yeah, your options of comfort or the safety installations are like area, priority, elevator, and etc. Sprinkler. And then here on the right side, you have some options for electrical panels with currents above 63 amps. And here, for example, a panel with 263 amps and a small one that's smaller than the 63. And also here, again, the same. What's the difference between this one? That's TNS earthing system, and for this one it's TT. So the difference is you have a differential protection unit here on the top, and here you don't have that. So we push the differential so as far as possible and into the
Oh,
scheme.
okay. I thought we still need that one in the top and for the last 35 we don't need it. Uh, or maybe it's different.
For the last, sorry.
For the last divine, the divine in the end of the scheme of the wiring. I mean, I don't know in English, but I mean that the the cut the is something like, let me check in English.
Yeah, go ahead.
Yeah, it's leakage current.
Yeah.
Yeah, I mean,
Ah,
yeah,
yeah,
that,
for the
yeah,
differential units.
yeah. So for the TNS, we don't need it for the, yeah, yeah, I see. Yeah,
Yeah, and indeed, we don't need it on the
yeah.
normally you don't need a leakage, well, a differential unit, so an earth fault detection unit, and a TNS earthing system. But then you need to calculate all the cables on full length. So then you need to know how far a socket is or a light fixture is, and you need to calculate that. If you don't want to do that, you can put a differential unit in front of it, and then you don't need to calculate it. So that's the why we do it. Otherwise,
Ah,
you
o-
need a whole calculation of the whole system, and that takes a lot of time. So
okay,
here in Belgium, we solve that by just putting a differential unit as far as possible in your installation.
okay, I got it. Yeah,
In industrial situations or industrial processes, you don't apply that and you just do calculation of the whole system, and then you don't need them. That's correct,
yeah,
yeah.
okay, yeah,
And then for the TT, still, yeah, you need it on the in the beginning of your installation, except for the yeah the type of differential protection units. You have a type A and type B. And B cannot never be after type A. Do you know the difference?
no,
Yeah, so you have it. No, that's not a problem. So you have for a loading and charging station for a car, for example, or for an elevator, those have frequency drives. Those frequency drives causing a DC current in your AC current. So they have a DC components in your voltage or in your
oh,
system. If
okay,
you work with that, you have they creating a DC component. That DC component is a distortion of your system. So that can be a problem for your type A differential unit. So it's how I call it uh, yeah, it causes a malfunction of the system or of your differential system type A. So mostly it can't be above says 6 milliamps DC component in your system. That's why they use a type B differential unit that can cope with that. So that's immune to those DC components. So, but
okay,
you can't put a type B after type A, well, because a type A won't work anymore if you put a type B behind it. So that's the short explanation. So that's why we always place type B differential units parallel with the type A. So on your main TT net, we have a type A on the beginning of your installation, and that's regulation by at RA here in Belgium. So, but to avoid that we have a problem with installation, we need to place type Bs on the left and the charging stations, and so those are placed parallel on the top of your installation. That's why you will see it like this. If you are in a TNS system, you don't have a differential unit in the beginning of your installation, that doesn't matter. So if you, for example, you have a charging station, yeah, end users here, for example, you just can have your main switch, and then you have type B differential units here, and then
yeah,
those
okay,
ones will be type A's again. So
yeah,
that's a little bit more of explanation. So if you see something like this, that's why, because the DC component gives problems.
yeah, okay,
This is also an exception on the regulation here in Belgium. Um, that's that. Yeah, and then you start at the beginning of your installation with your high voltage room. Um, After your high voltage room, you have a board, an electrical panel for the high voltage with the several departures for the equipment inside the main voltage cabin. For example, you have the CE socket for 32 amps. That's to connect measuring system of the provider. Then you also have the sockets in the cabin itself, the lighting, the emergency lighting. Then you have the control unit for switching on from a distance. So you have that needs also need a feeding. So the provider can switch the main and the entrance and the departure switch. They can switch it from the central control center. So from a distance, and therefore that unit also needs a feeding. You have your minimum voltage protection unit for the transfer. So if the current from the net is down, then your switch needs to go open, and that's the feeding for that one. Also for the ventilation of the cabin and also for the heating of the cabin. So those departures are here, and also on the you have your protection unit, the HPT, on your transformer. So that's the control unit that looks for temperature, gas, and etc. If there's a fault, it will shut off the installation. So that's also that component also needs a feeding from an electrical panel, and that's this one. Um, from that panel, then you go to your ALSB or all your other electrical panels. Um, and then yeah, then what you do is always what I do is always I put my main biggest consumers on the top, and then afterwards we have the different smaller ones like an elevator, charging stations. You have your fire central intrusion detection and so on, data racks. And then you have yeah, here you have the safety installation where you have your UPS, your IT net, your conversion from a TN to an IT net for your safety equipment, like your area and your pressure pump for your fire hoses and so on. Afterwards, we're going to make different groups for lighting and for sockets. We always say about 9 departures after one group differential. So uh, why do we do that? Yeah, it's through phase connection. So we say we have 9 departures. So this is monophase. So you have 3 times 30 amps per phase. So it's lower than the 40. So it's okay. And also, if you have a problem, if you have a fault on this one, an earth fault on one departure, the differential will disconnect, and then you only have a failure of 9 circuits and not more than that. So that's a bit the reason behind it. Here's some explanation about outside lighting and so on, and then you have again the sockets um, where for sockets we say okay 6 departures after one differential. That's the main thought. So again, to make sure if you have a fault, you don't lose a lot the whole installation, but you only lose 6 circuits and not all. Um, then it's each time it's the same. For wet areas, we use a 30 milliamps. For dry areas, it's a 300 milliamps. And then you also have the last one are critical consumers less than 4 kilowatts. So if you, for example, if you have an equipment that you say it needs a direct feeding, for example, from a machine or something like that, then you can give it a different his own protection unit and his own yeah cable. So not on after the group differential. So if you have a fault on that, it's only disconnect this one and not the whole group. So that's the main explanation about an electrical panel. I think then do you have questions about that? Otherwise, I will go over to the block scheme and a bit more explanation into the project itself.
No, for this one, I already got it. Okay.
Yeah, okay,
Yeah.
perfect.
Okay. Thank you.
And then whoop, I'm going here, going to the block scheme. Right, first I will take this one. Oh, I meant wrong folder. I need to be here. Block scheme. Yep. So that's always a good start to start your one wire schemes. So you have an idea on how the everything is connected. Um, if you look at my remark here, I placed no, it's another one. It's a little bit different. So what we will do is we have our main voltage from the provider. Oh, it's a private cabin, so it's our installation. From there, you have your transformer. Then you will here we have an electrical panel for the main voltage room. From the main voltage room, we will go to the main electrical panel for the parking area. Yeah, and from there we have no, this one will be connected to here, and also the general parts for the apartments will be connected to the low voltage counters. So for only the parking area will be connected to the transformer. So
Okay.
from there we go to the electric panel, main electrical panel for the parking area. We go to this different sub electrical panels, and but here you also need a connection to the electrical
Vital.
panel for the vital installations. Yeah,
Yeah.
and then from the generator itself, we had again I have an electric panel for the generator and all its uses. And then from there we go to, again to the vital installation where we have a switch that connects that chooses the generator or the primary source. After that we have the IT transformer and again the RWA parking and some other vital functions like the pressure pump, Astrid, and so on. So if you have that, that's okay. And then we go to the one wire scheme. No, it's again. It's still early. I'm not awake yet. Yeah, okay.
Okay.
So we have the distribution cabin that's on yeah, outside the building. So that's from the provider. It comes, it arrives with two feeders. Those feeders are supplied by the provider and not by us. So our installation starts here. Then we have our entrance, arrival and departure unit. The M here is to indicate it's motorized, so they can open and close it from a distance. Now this scheme is a little bit old because now we also need a motor on this one. So we have an arrival and departure that is automated and can be controlled from the distance. So we need to add here also motor. I don't know if we have
Okay.
it in the typical schemes yet. Yeah, if you look at the
Yeah, I
typical
see.
schemes, you
Mm.
will see it's already there on the correct way.
I see moto in the last one too. The
Yeah, okay.
DX.
Yeah.
So we need both three of
And the
this one.
DX, yeah, the difference between a TX here, TX, and you have a DX. A TX is with a melting protection unit, so it was with fuses, and this one is with I always miss in English. RCB or not RCA or I don't know. Maybe it's high power switch. How do you call it in English? I don't know. Is that
I don't know.
okay? I will search for it and we'll let you know.
Okay.
It's protection units for higher voltage. So here you can see it. If we have a transformer above 800 kVA, we use a DX. If it's lower, we use a TX. But both can be optimized and motorized. So you have the
Okay.
motorization here, and also this is the voltage detection. So if there's no voltage on those cables, this one will give a contact to this one switch to this switch and will open that switch to protect the loop here. So we can't put electricity into the net. So if they're working on the net, the installation needs to cut off. That's the why, the U values that is here
Okay.
indicated. Um, all right, back to the other one. So then we have our transformer. That's okay. And then we have our again our electrical panel for the main voltage room. That stays the same that I explained previous. Okay, then we go to the parking. We have a main board for the parking. Here it's a bit different. We have I placed electrical panels for the charging stations, so they won't be connected to the each main electrical board for the parking, but we'll have their own separate electrical panel. What we have is the
I saw I saw that I already can count how to say calculate, and the ampere of that boat is around 1000 ampere.
yeah,
I
but
mean, so
on the charging stations we don't have uh, but we use a simultaneously factor, so we don't say all the loading poles are or charging stations are on maximum loads on the same time. So we'll determine, okay, we have four on the tamps divided under all the separate charging stations. But normally, I think I made also, and I didn't share that yet, a power balance. Yeah, I will send that through to you. Um, so in the power balance, I made an estimation about the power for the transformer. So I will send it, and here you can see I counted with the charging stations, but
mhm,
I will make it a little bit bigger. So I have residential as on the min two, minus two level. So that's
yeah,
purely um, for the apartments. So it's
mm,
outside underneath the apartments.
okay.
No, was it?
I see the
Yeah, it was
the
not.
factor KS is very
It's not
very
like that.
low.
Yeah, 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 yeah. Why I did that is because
It is
the
only
parking.
0.05 or
Yeah,
0.5.
yeah. The reason behind that is because it's a parking that's open for residential units. So for the apartment buildings, that is on top. But the parking will all be also be used for public use. So the idea behind that is during the night, those people will charge their car, and during the day those people will use the charging stations, so your simultaneously factor is very low. So we say, okay, we take the biggest one, and the biggest one is the commercial side. So if you calculate with that power, and not with this one, it will be realistic, I think, because they don't won't be used on the same time, right?
Okay, yeah.
Yeah, but we have that the power will be limited. So okay, we say that's the power we use for the charging stations. You can't go above that. If the people are home and charging their car during the day, yeah, then the other ones will have lower power. So it will be divided and regulated. It will be regulated with software package.
Okay.
So here you can find what the idea behind it is. Then we have the elevators and so on. And then I saw we have a transform. We need a transformer of 630 kVA. I will send that file to you also. Um,
Yeah, thank you.
let's see. All right. Um, and then we have our main electrical panel for the parking area. I will open the plans because I can show you what the ideas. Um, so I have placed an electrical panel for the charging station here, and also one over here. The idea is to connect all the charging stations that are here.
Yeah.
So those are the residential charging stations to that panel. And then all the commercial ones, those are here. And on the -1 over here, those will be connected to this panel.
Okay.
All right. So we'll have two panels for charging stations. The only thing that they feed is the charging stations itself. So no lights, no sockets, only purely the charging stations.
Okay.
Um, what did I do also is we placed here a 5G6 square meters cable because it's a 32 amps 32 amps feeding. For the residential unit, we will divide that 32 amps to 2 times 16 amps, one for this side, one for that side. Yeah.
Okay.
For this area, it's the same. For the -1, if you look at the -1 here,
It's bigger.
yeah, here on the right side, it's bigger. It's each time 32 amps. They need to have 22 kilowatts for each car. So then we need two feeding lines. So um, yeah, those charging stations here, sorry, here those charging stations will can supply to each side 22 kilowatts. Um, the charging stations that are over here in the residential area also have oh, the mines too also have 22 kilowatts, but they need to be divided for two cars. So if they're parked one car, it can give 22 kilowatts to that car. If there are two, they all get 11 kilowatts.
Okay.
So that's a bit the idea behind it.
Okay.
But
So
for
it's
the scheme, it's the same. Eh?
yeah.
So each cable has a departure of 32 kilowatts. Sorry, 32 amps, 22 kilowatts. Right? Um,
Okay.
do you need to explain more? No, that's it. And then for the, yeah, go back to the plan. Then for the other ones, we have the main electrical panel for the parking area. That's over here. So, and we have another one on the -2. So my idea was to connect, yeah, what was my ID? uh, the other one was over here. I don't know, this one. Yeah, for each level one panel, I did change. Oh no, sorry. So yeah, okay, it's coming back. You have the main electric panel here, so that provides all the main feeding lines. So for example, you have the cables here for the data cabinets. Uh, then also you can take the technical spaces here can connect to the main electric panel for the parking area. Um, and also that one feeds the generator. You need two feeding lines for the generator, one for keep it warm, and one for charging the batteries of the generator. Um, and then also for the feeding line for the main panel for the vital installations, those will be connected to the main board for the parking. Then we have here on the -1 electrical panel and on the -2, they will
Okay.
provide the feeding for the lighting, one for level -1 and one for level -2.
Okay.
Right?
Okay.
Um, then I mentioned in my remarks, we need another electrical panel here next, move that up and put an electrical panel here next to it for the general parts of the apartment buildings. The general
Okay.
parts, that's, I mean, the staircases and everything that's above zero.
Okay.
Yeah. So all the technical spaces here, for example, the bike storage and so on, that will be connected to the electric panel here. So
Okay.
everything that's only for the apartments will connect to yeah, the main electrical panel for the general parts of the apartments. That will be over
Okay.
here.
Yeah.
Um, if you make it, yeah, keep in mind that you, for example, you have that you divide it in the several sections. I mean, you have for example, the feeding of the elevator for, yeah, let's say staircase one, and then you have lighting, you have sockets. Put that together, and then also you have that three times. So if we
Yeah.
need, we can put a counter before it, and we see the consumption of that part of the building. Yeah, a bit logical build up of the installation. Um, And for the rest, yeah, it's lighting for the parking area and the bike storage here. It's a dolly system. So what you have is just a feeding line for the technical rooms and so on. We have push buttons so that we need interrupters, switching relays to control that lighting. So what I do mostly is yeah, we use two or three circuits for the parking area, mostly um, about maximum 30 light fixtures per departure. So if you have a departure of 10 amps, you place a max of 30 lamps, light fixtures behind it. All right. What
Okay.
we will do for the control of the lighting, I mentioned also we will add two sensors here. So when the car drives in and it goes that way, we don't need to the lights go on this side. But we will use DALI, so we can say, okay, we put yeah, that light at 10%, so it's not dark, but you don't have a lower value of light. And if you drive in that section, it goes to 100%. So that's the idea behind it, right? Um, so for the scheme, yeah, it will be a little bit the same as the one that's in it, but yeah, it's a smaller building, so we have to reduce the number of panels. So yeah, we don't have an emergency panel that this. So we have a generator. We have the main panel for vital installations. That's correct. Here we also have a departure for the area. We don't have that panel. Um,
Yeah, I don't change anything on that.
no,
Yeah.
no, no, no. But I want to
Yeah.
indicate what we need and what we you can delete.
Okay. Yeah.
Um, so for example, this one, you can delete that one, and keep this one, that one, okay, you can keep also, and then, yeah, delete that one and put the panels for the for charging stations here. Oh no, that's for the general parts. Yeah, sorry. You can use that one also for the general parts, for the elevator, for example, and delete the departures you don't need. It will be much smaller than this one. Um, Yeah, to define here, so you have the main panel parking. In the past, I did it with a central programmable unit that switches on and off the parking lighting. In function of the detection, it happens. And always you have one light. If you have three lights, those three lights were each time on a different circuit. So then told circuit one always stays on, and two and three are switched when you have a presence in the area. So that was it each time circuit one, two, three, one, two, three, and so on. So that's a bit the controlling that I did here, but now I will change that to a DALI system. So there's just a departure here, lighting, parking, dolly, and that's enough. This for each level we have that we'll have that three times, and I think, and that's it. Um, yeah, that's a bit of explanation about it. Do you have questions, or do you see? Yeah, for the section of the cabling, yes. Um, If it's smaller than 60 amps, you can follow a rule, and the rule says, for example, I will note it down and send it to you. If you have 16 amps, it's a 2.5 square meters cable. If you have 16, then you have 20, as also 2.5. Then you have 25, that's 4 square meters, and so on. So we have a general rule, and that goes up to yeah, 250 amps. If we go above to 50 amps, we need to calculate it with Conoco. Um, but I
Normally
suggest
we
if
yeah we
uh,
don't have Canicor. yet
Yeah, you
or
do have
something.
it, but you didn't have an explanation yet. No,
Yes.
normally
Okay.
David will give an explanation. He told, oh yeah, he asked that, and it was approved by management. So normally you should do it in the future.
Okay.
Um, but yeah, or perhaps we can do it together. Then you
Yep.
always
So,
already have to have done it one time. Um, so for
but
the
how do we know the ampere of the whole, for example, like the whole parking? Because we need to calculate the wiring, right?
yeah,
And we need to calculate mm,
yeah. So
the protection
yeah,
device.
indeed. So you have a transformer of 630 kVA. So that's not correct. Wait.
That one
Uh,
I have not changed yet.
no, no, no. So if you have 630 kVA, you can put 913 amps through it. So here we'll have a protection unit of 1000 amps that regulate it to 910 amps. So that's the way we calculate. We see what's the main circuit breaker. So you just look
Okay.
at the power of the transformer, and that will be this one.
Yeah.
Then you will have a departure to the main electrical board for the parking area. That will be a switch with the same amps that go through here. So that's thousands, and here it will be also thousands. So, but the maximum will go through as 910. From there on, yeah, you need to look at the power balance. We have the power balance here again, the XL. Um, go. Normally, in detailed phase, we split it up for all the electrical panels. For example, we do the same. We just say, or we can do it, make another column here at the back and say, okay, that's on board. So electrical panel 1, 2, 3, and then see what's the sum of that at the end. But be aware to have selectivity on the protection units, so that the protection units first in your circuit will shut off and your first one not. That's selectivity. If you want to reach that, you have a minimum current of 63 amps. So we will never have an electrical panel that's lower than 63 amps, a main electrical panel, just for the selectivity. So if you have a failure on the installation, for example, on the -1, then the electrical panel of the -1 can shut off, but not the main electrical panel of the parking. So to reach that, of to get to that, we need an electrical panel of minimum 363 amps or maybe 80. Um, so specific here, you will have an electric panel for the main electrical panel. That's this one. That's defined already. That's the 910 amps. Then you will have the electrical panel um, for the residential circuits, for the residential charging stations. We have 18 charging stations of 11 kilowatts. If you just put this one on one, for example, or no, we put it on no, 0.6. For example, we can see, okay, we have 250, take it 250 amps protection for the VB charging. Wait, okay, put that. I was just thinking that I will put it somewhere so we know. I can put it here. That's VB lot one. It will be 250 amps. And then those two will be connected to the other one. So then you just need to take that current here, and that's 430 amps. Yeah, we can say it's 400 amps or 630. I think we should say it's 630 amps for that one. So I will put that here. That's, for example, VB load ball 2. That will be 630 amps. And also this one will be connected to that one. And then you also have the ones for the lighting of the parking area. So you see that's very low currents. That will be that's maybe I will show it on the plan because I'm going too fast, I think. Um, oops. So this panel here is different. So I change it here. That one will be VB pole 2 and this one will be 1. So this panel will be 250 amps. Do I make an issue that it's clear or is it okay?
It's okay for me. Yeah.
Okay, so this will be 250 amps and the other one that's over here, that one will be 630 amps. Yeah. Um, and then we have again two panels here, VB parking 1 and 2. Those will be 80 amps. Why? It's a very low current, but we need the 80 amps for the selectivity. So we don't look at the consumption of the panel, but to the selectivity. So we calculate the cable also on 80 amps, and 80 amps means that it's 25 square meters cable if it's lower than 60 meters. I will make a quick indication how I get to that value, so it's clear for you.
Okay.
But I will do it on paper because yeah, it will be more clear.
Yeah.
So
Okay.
that's a bit how I'm thinking about. What you can do here is just eliminate all the consumptions. For example, for the lighting, if you put that on 0 and for the sockets on 0, then we have still have the sewage pump, the booster pump will be and the fire boosters. Wait, no,
So I will
no. It
connect
does.
to the parking too, or no?
Yeah, on a different one, but you will see it's just that it will be 23 amps divided by 2 because you have two levels, two panels. So you only have 16 amps for that electrical panel. But
Oh.
why do we do it in a separate panel? Because the distance of the cables. Because if you stay below 60 meters, you will stay in the same section of cable. So, for example, if we go to the furthest, it's from here. We are here already at 60 meters. So if we go to the other side here, we will have too high voltage drop
Yeah.
to that side. So that's why I placed the electric panel here and also on the -1
Okay.
because it's more centrally divided for everything.
Yeah.
Yeah, that's a bit the information that I have for to make one wire schemes. I think start with it, and if you have questions, let me know and I will explain more.
How about the wiring? The size of wire?
The size of the wires.
Yeah.
Yeah. For lighting, it's always 10 amps protection
Yeah.
unit, and for lighting, we always use 1.5. For and then we have
Electrical
a
cord.
yeah. Wait, and then you have for example, we say 10 amps for lighting. That's always three. Oops, no,
3G. Yeah.
3G 1.5, but here we
Yeah.
work with Dolly, so you need to place 5G and 1.5 because
Ah. Okay.
we use 3G 1.5 for your
Yeah.
feeding and two cables for the Dolly bus.
Yeah.
But you can incorporate that in the same cable. That's the advantage of Dolly. So, and then you have the 60 amps for the sockets. There we place always 3G 2.5, and then it goes up. So you say 20 amps, that's the same. In the past we use 20 amps, now it's 16. Then you have go to 25, then it's
5.
on yeah, it's not, it will be three phase, then you will have four. Those are standard
52.
values. Yeah.
Yeah. Okay.
And then you have six, and wait, I will do it directly, then I already made it. So you have 5G10 for 63 amps, no, for 40, sorry,
What? Yeah.
40 or 50. Then you have 63, that's 16, 16, and then you have 80, 100, 125, 160, 200, and 250. If you go above that, we need to calculate it. So here you have done 5G 60 or 25. 5G. Here it becomes 4 times 35 plus 16. You know, here is the PE is integrated in the cable. Here it doesn't exist anymore, so we need to put it separately. So here you have 20, 4 times 70, and 4 times the 5. I missed somewhere. Did I?
And
No, no, it's correct. It was 50. And then you have 4 times 120 plus 70. So that's the general rule if you stay below 60 meters. I calculated that. Um, General rule below 60 meters. So if you go above 60 meters, you always jump one section. So if you go to, for example, between 60 and 90 meters, uh, go one section higher. If you are between 90 meters and 120 meters, go two sections higher. Is that clear? So, for
okay,
example,
I
if
got
we
it.
have
Yeah.
a cable of 25 meters,
Yeah,
25
but the
amps,
length of the
it's
cable
yeah,
is longer than
yeah,
the 860. We will go higher. It will
yeah,
be 23, 32, 32. Sorry. Yeah, but it's yeah, I
yeah,
got
yeah,
it. I
yeah,
got
yeah,
it.
yeah. If it's 100 meters, for example, I want to have 25 amps, you need to go to 10 current.
40
Yeah,
amps. Yeah.
yeah. So that's the general rule we use.
Okay.
And for the rest, yeah, we need to calculate it.
Okay.
So for an apartment building, you never go higher than this because also the rule of 60 meters is if you use the complete current. So for example, if you have a 60 amp protection unit and you go to and you only have 10 lighting fixtures, you need to calculate also the distance to the furthest one, and the furthest one has the lowest consumption. So that all the consumption also have a, a part in the voltage drop. So for that, yeah, if if you would take 16 amps at the end of the circuit at 60 meters, you will have a problem. But if you only
Yeah.
take 1 amp at 60 meters, you don't have a problem.
Yeah.
So that's a bit the idea behind it and the technical explanation.
Yeah,
But that's
okay.
the general rule. If you follow that, 80% of the cables are already correct. Okay.
Okay, I got it.
And then one last thing, I think it would be interesting. We also I didn't don't know if you already see that the cable list. We also have a cable list where we do the measuring of all the cables in the building. Um, for now, we always made it ourselves. But yeah, if you want, and if you also need to measure it and you make your schemes, it's easier that you first make this one. Why? If you just see, hey, for example, here, say we have Hoofdborg parking, and it's the consumer as, for example, we have the data costs, data rack. Its type of cable, it will be an XGB because it needs to be halogen free. So if we have residential, will be I don't know if it's here already. No, for residential cables, it's a H07V1, which I can indicate that it's in the list here also. So you have this one. Um, and then you just have parallel cables. No, we have one cable with the cable section. Okay, it's the data closets. It's a very low consumption. It will be 3G 2.5 here. And then you have your polarity. It's monophase. And then your consumer, yeah, it's a data closet. Say it's 2 kilowatts. I don't care. A power factor 1. And then you say it's a circuit breaker of 16 amps. For example, data racks are here already filled in. So the typical departures are already here, so you can look at that. And then you say, okay, we have a horizontal path. So horizontal, we run about 4 meters. We go vertical. So you're muted.
That means is the cable length from this room to the other room from
Not from the room,
this.
from the panel to the end consumer.
Yeah, yeah,
Yeah,
yeah. Okay.
it's a bit, yeah. And then you, for example, horizontal, you just measure it on your plan. Then you know the
Mm-hmm.
distance you to
Yeah.
follow the cable trace, and then you say, okay, vertical, yeah, you go 3 meters to the ceiling, then you go to the other room and 3 meters down to the consumer. So it's at six, and then if for each installation you need to calculate it a length of cable that you need to use as a backup. So the cable is laid before the electrical panel is there and also before the consumer is there. So you have a spare length.
Yeah.
So that spare
Yeah.
length you also need to
2 meter
define here.
for eight.
Yeah,
Yeah.
1 or 2 meters. I take one because they need to
Okay.
be more precise, I think,
Okay.
because we calculated 6 meters vertical, so that's already quite a lot. So we
Yeah.
say two, and we have two times the data cabinet. So then you can see here the total length here is filled in. Yeah, the link is if you have multiple cables for the same consumer, and you fill it in here too, then you will see it multiplies here but not here. So that's the distance between the electrical panel and the consumer. This is the total distance of a cable. So if you have two parallel cables, it will be counted here. But yeah, you won't have that here. That's for bigger
So we will
installations.
go on. Okay.
Yeah, so it will be here one. So if you fill that one in and we go to here results and then go to data, refresh all, we get the total list of the total lengths of the cables.
Ah.
We only filled in one for now. So you will
Okay.
see the 24 meters here is this one, lip, as this one. So if we do that, for example, yeah, up like this, up. If I mention it here, the easiest way is that you do it for every consumer. So if you say data cost one, data cost two, and puts consumers here on one,
One. Yeah.
yeah, then you see it's 12, 12, and if you say refresh, it keeps 24. So it takes it looks at the polarity. No, it looks at the cable here. At the cable, it looks at the cable, and it makes the sum of this column. So
Hmm.
then in our tender tanks, in our bill of quantity, we just take over this column, and then we have the total lengths of the cables.
Hmm.
Right?
Okay.
So yeah, that's it. If you can make
Yeah.
this one first, because it's easier, then you can say, okay, we have Heightsboard A, and then you have VB parking one, and then you say, okay, lighting. Lighting we don't measure. We just say the general distance between a light fixture and between the light fixture is, for example, 6 meters, and we have, yeah, for example, 200 lights. Then we do just like that. But if you look here lower, you will have some explanation, I hope. Push buttons, no lighting. Where's
So
lighting?
I don't understand about the lighting yet.
Yeah, for the lighting and the sockets, we don't measure it. We use a general value. That
Okay.
means, wait, yeah, here, if you look at the back, for example, between the electrical board and the sockets, with no specific use. Just for apartments, we use 6.5 meters per component. For other buildings, we use minimum 8 meters per component. And for KNX schakelaartoren, teleleptoren, we use 10 meters per component. So we just calculated, okay, we have a parking area, for example. We have sockets in there. Then we have 50 sockets. Then we say 8 times 50, that's the total cable length for the sockets. All right?
Okay. Okay.
Yeah, fill it in, send it through to me, and I will check it and give my feedback.
Okay.
That will
Yeah.
be the easiest way, I think. But look at the examples here.
Yeah.
So then you will see, oh, yeah, okay, that's quite easy. And if you have questions, for example, if you have said, okay, yeah, we have tracing in the entrance and the entrance of the parking and the bike storage. I don't know what's power consumption it has. Just put it in yellow. Then I will fill it in, and then we can make the schemes accordingly to that. So you see, here we're building up our electrical panel with our consumers. Here already we put our protection devices, and if you have that list, you can easily make your scheme.
Yeah. So this one is for everything. I mean, even for the apartment too, right? Or just only the parking, the general
Just
part?
make this for the parking.
Okay.
We use this also for the apartments, but I will do that myself. You don't need to do that because it's just two lines and I made it. So the only thing is would be interesting if you do it also for the apartments, but then you put here, for example, counter room, so where the low voltage counters are, and then you go to VB uh, apartment one, and then you can fill in here. Yeah, the section will be 5G10, and then here you can fill in the distance. Then we already have that's the between the counter room on the -1 and the storage unit of the apartments. Then we
Okay.
also have the distance main distance between well, the cable lengths of that one. So that would
Okay.
be easy if you do that also. And be aware if you come here, for example, above 60 meters, then you need to go up with this one.
Yeah. Yeah.
Ah,
Yeah. I
no, no,
got
no,
it. Yeah.
no, no, no.
Uh,
I'm mistaken. Sorry. The apartments here are three phase, 20 amp, 20 amps of 25. Wait, where can I see that? Um, just check. Basic design. No, yeah, concept. Um, apartment buildings, rijwoningen, appartementen. Yeah, they will connect to 32 amps. So yeah, 32 amps, but always take a minimum of 10 square meters for cabling. So to make it easy, um, that's applicable. What? Will be note. That's applicable. So the minimum section of a main cable is 10 square meters. So that's applicable until 90 meters. If you have a distance above 90 meters,
okay.
you need to go a section higher.
Okay.
All right?
Okay. Okay.
Yep. That was a lot of information.
Mm. Thank you. If I don't
Um,
understand anything, I will come to you.
yeah, perfect. Right. If we don't have
Yeah.
any questions anymore, we can end the meeting.
Okay. So thank you very much.
All right. See you later. Bye bye.
See you later. Bye bye.
Thank you.